we're going to focus now. So next section we're talking about quadratics. We'll spend a couple days on this. Right now we're not solving their equations, we're focusing on graphing them. And then we'll get into the actual solving later on. So first thing, this chapter we're leading into, this chapter is all about quadratics, but the next one will be about polynomials. So I'm going to start throwing around some terms that you're going to hear me say a lot when we talk about polynomials. So if we have a polynomial degree n, where n is a non-negative integer, then the polynomial is defined by this. So there's a box at the top of your notes handout, and you're kind of filling in the blanks. This looks kind of ugly, but what it's saying, n is a non-negative integer. So it's like 1, 2, 3, 4, 5. Those represent the powers. These a's are the coefficients. It's basically, we're adding up powers of x, and they can have different coefficients in front of them. So anytime we see something of this form, we can call it a polynomial. Within this, there are some words that you're going to hear me say a lot. So if I talk about the degree, that is the highest power in our polynomial. So the n is our degree. If I talk about the leading coefficient,
dude, this water bottle is making me mad. It's like,
is it rounded on the bottom? Okay, the leading coefficient. So the coefficients are these a's in front. It's the coefficient of the term with the highest power. So think of that as the a sub n. Landon, I'm teaching. Shh.
Snap.
So your constant. A constant is a term without a variable. So in my scenario up here, it's the a sub 0. So those are some common words you're going to hear me saying, starting now, but especially as we get into the next chapter. These things are going to be very important. So the first example I have is just a little bit of practice with these polynomials. I'm going to give you 3 polynomials, and I'm asking for the degree, leading coefficient, and constant of each. Does everybody have all these definitions filled in on your handout? So when I look at this, my degree, what is the highest power of x? 1. Leading coefficient. So here's where I have my highest power of x. What's the coefficient of that term? 5. The constant. -1. Just a word of warning, it's typically written in standard form so the powers of x decrease, but it doesn't have to be. So don't just assume that the first term is going to be your degree and your leading coefficient. You need to look at all of them. So the second one, what's my degree? 4. Leading coefficient?
1.
Constant?
0.
0. We don't have a term without a power, so my constant is 0 there. Last one. Degree. 3rd. Notice I flipped the order on you this time. But if you look at all the terms, there's the one with the highest power. Leading coefficient, so that's the coefficient of that term.
-1/2.
And the constant, that's a term without a variable, would be 5. Any questions about that? So the rest of the day, we're going to be dealing with a specific type of polynomial. One last thing to mention along these lines. If our function is just equal to 0, we call that the 0 polynomial, and it has no degree. The reason is 0 is the same as 0x or 0x squared or 0x cubed. I could put any power of x with it, so I can't just pinpoint a single degree. It's different than if I have just a function equal to a different constant. 3 is the same as 3x to what power?
-1.
0, because anything to the 0 power is 1. So if it's 0, it has no degree, but if it's just any other constant, we say it has a degree of 0. Right. So what's a quadratic function?
AX. Or
Oh my
X
god.
squared.
Standard?
Yeah, that's fine.
AX plus BY or AX squared.
AX squared plus BY. No, hold up.
AX squared
Plus
plus
BX
BX
plus
equals C, or plus C, excuse me.
Okay.
So quadratic is just a polynomial of degree 2. So this is what's called the standard form. So that box, the quadratic function, is a function of the form f of x or y equals ax squared plus bx plus c. We've seen some quadratics already, haven't we, when we talked about our parent functions? So we'll use some of that information to help us today. When you graph a quadratic, what does it look like?
Parabola.
Parabola. So the graph of any quadratic is a parabola. And we have two options. The graph will either open up or open down. And whether it opens up or down will determine if it has a maximum or a minimum point. If it opens up, what does it have?
Minimum.
Minimum. If it opens down,
Maximum.
it has a maximum. What's the name for that maximum or minimum point?
Vertex.
The vertex. We can also talk about, when we graph them, we'll talk about the vertical line that goes through the vertex. Do you guys remember what that was called?
Axis of symmetry.
No, I meant.
I mean, it is the center, so kind of like a midpoint, but the axis of symmetry is the vertical line that divides it into two equal halves.
We're grabbing.
Huh?
Oh, you. Do some graphic.
Mm-hmm. What's it there?
Okay, so next thing, we're going to talk about graphing these. And the strategy that we will use for graphing depends on how the quadratic is written. So the standard form is the form I already gave you. Ax squared plus bx plus c. It could also be written in vertex form, which is what we saw when we were using transformations.
X plus O. That's right.
Yeah, sorry. I put it up before I asked you. So when we do that, we can get our vertex from here, thinking about, it starts at 0, 0, you move left, right, up, and down. All of our transformation rules are still true, so nothing has changed there. so we're going to start graphing a few of these. How are you? So the first one, this was in standard form, x squared plus 4x minus 4. When it's written in standard form like this, can I tell my transformations for graphing purposes?
No.
No. So let's just make a t-chart. That's what we do in general when we don't know how to graph something, right? Just hold on.
Okay.
Were you going to give a different suggestion?
We could, yeah.
Yeah, I'm going to make a point before we do that.
Okay.
So give me some values. What can I plug in?
0.
0. So if we put in 0, we get out
Negative.
-4. Okay, if I put in 1, I get 1 plus 4 minus 4, which is 1. If I put in a 2, I get 4 plus 8 minus 4, so we get 8. Do I need more positive numbers?
No.
No, it's just going up. So if I put in some negatives, if I put in -1, I get 1 minus 4 minus 4.
It's just gonna reflect across the same.
But it's not yet. -1 gives me out -7. So I need to keep putting in points because I don't have a parabola yet. So if I put in -2, I get 4 minus 8 minus 4, so -8. So have I found my vertex yet?
Yeah.
Maybe. Let's keep going because we don't have both sides yet. So if I put in -3, we get 9 minus 12 minus 4.
Thank you.
So that's -7. So now we finally found our vertex. So what we know is there's a vertical line, the axis of symmetry. If you draw that in, we can draw a dash. That cuts our parabola in half. So if you have points on one side, you can reflect them over this line to get points on the other.
You're missing something.
So now I have a lot of...
Congrats on the wrong question.
Don't worry, Mr. President, I got you. I know the trick.
You know the
for
trick?
parabolas.
Good.
Not really. You just gotta find the first point, and then you go 1, 3, 5, 6. No,
9,
1, 3,
11,
5, and then
7,
7.
9, 11, 13.
What are you all talking about?
What is
That's
the
how parabolas are.
domain of this? What is the range?
I did something wrong.
Okay, so what we did worked. We got the graph. Why is this maybe not the best option for graphing these?
It's not fast.
It's not fast. We had to keep plugging in points until we found the vertex, right? If my vertex had been at like -3/5, would we have probably found that just by plugging in points? No. So this kind of gets us there, but it can be very time consuming and it's not very efficient. So that's really not the route we want to take with these. If it's written in vertex form, we can do transformations. So let's try some by transformations. If you do transformations, just like we've done before, what do I expect from you?
Parent function.
Parent function. So if you're going to do transformations, we need our parent function. So 0, 0, 1, 1, 2, 4, -1, 1, -2, 4, just like we did back in chapter 2. Okay, what's the negative going to do?
Flip it.
Over.
The x-axis.
What's the 2 going to do?
Stretch by 2.
Essentially, all we have to do is take the y value of these points times -2. So 0 times -2 is still 0. 1 times -2 is -2. 4 times -2 is -8.
You could do the trick for this one too. you just multiply, or instead of 3, you do 6.
Mm-hmm.
What's
Good job,
that
Carson.
domain?
All real numbers.
Negative, negative, positive.
That one.
Isn't it like always negative, negative, positive?
Yes. What's the range?
It's
0 to
negative.
And 0 gets a bracket because
Okay.
we do hit that point. Alright, you guys try the next one. Use transformations. Parent function transformation gives me domain and range.
There's always, I don't know why, but like, I'm used to like having all of the equations on the walls.
Yes, boy. So parent function, 0 squared is 0, 1 squared is 1, 2 squared is 4, negative 1 squared is 1, negative 2 squared is 4, so that's my starting one. Transformations. How is this one going to move?
Down one.
Right 3 down 1.
Mm-hmm. Where's your vertex end up?
3 1, 3 negative.
You missed it.
Close enough. Domain.
Negative,
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 negative, positive. Negative 1. Bracket negative 1.
I completely forgot about that piece.
Yes. Equal to's get brackets. Infinity always has the parentheses on it. Alright. Are we okay with the transformations? And you could give me the vertex, domain, and range from those graphs?
Yeah.
Alright. So if it's written in standard form, like the very first one we did, we know plotting points is not very efficient. We need another option. So there is actually a formula to find the vertex. So it's x equals, remember?
No.
Well, x sub 1 plus y sub 1 or something. Oh, no.
2A.
Opposite of b over 2a. That gives you the x value.
By
Oh,
the
the
way, that was on the
vertex.
scouting wall.
Oh.
There's a formula for y, but I think it's easier just find your x and then plug that back in to get the y rather than trying to memorize another formula. So we can get our x that way, plug it back in to get the y. Axis of symmetry is just the x value of your vertex, so it is the x equals opposite of b over 2a. Make sure on those, anytime I ask you for it, I'm asking for the equation, so you have to have that x equals. So if you just tell me axis of symmetry is 5, that's wrong. It would be x equals 5. So make sure you're giving me an equation for that. How do you get a y-intercept on the graph?
Plug it in.
Plug what in?
The vertex.
That gives you the y value of the vertex, but I want the y-intercept.
Putting the axis of symmetry.
Yeah, x is 0, so you plug in x equals 0, you get your y-intercept.
Oh, okay.
And then you can reflect that across the axis of symmetry to get the full graph. So anytime you graph these, you have to have a minimum of 3 points, and I really told you how to get 3 right here. You have the vertex, we can get the y-intercept, and we can reflect that over the axis to get the 3rd point. So let's try that on a couple. All right, so I'm going to ask a bunch of questions on this. First stop, I want the vertex. So opposite of b, so my b is
Negative.
so -2 over 2 times a is 1. Remember, it's ax squared plus bx plus c. So we get -1. To find the y value,
Plug it in.
you plug in -1. So we get 1 minus 2 minus 5, -6. So when I'm asking these questions, I'm going to look for proper notation. The vertex is an ordered pair. So put these two together to give me a point. Vertex is -1, -6. Then I'm going to ask you for the axis of symmetry.
X equals -4.
It's just x equals the x value of your vertex. Then I want the y-intercept. That's where you hit the y-axis, so x has to be 0. So if we plug in a 0 for all of our x's,
-5.
Alright, let's graph this part before we do domain and range. So my vertex, -1, -6. Axis of symmetry, that would just be the dashed line here. Okay, we hit the y-axis at -5. And then you can reflect that over. So I see that's 1 away from my axis of symmetry, so we go 1 the other direction. That's my 3 points. If you wanted more, you can just plug more values into your equation. But this is enough for me to kind of get my graph.
Do you want us to write the y-intercept
As an ordered pair. Unless I specifically ask for it that way, I won't care.
Okay.
You should be able to, but I'm generally not going to care. What is the domain? What's the range?
-6 to
Bracket.
Gosh, Carson.
Can you tell by looking at this equation if your parabola is going to open up or down?
yes.
Yeah.
How?
No
Okay.
negative.
We know a negative flips it upside down, so that's when it'll be upside down. All right, let's try a few more. So this one, can you tell me, is it going to open up or down? Okay. So have to start out to get our vertex. X equals opposite of b. So b is -6, so the opposite would be +6 over 2a. So we get 1. Plug that in. So I get 3 minus 6 plus 7. So how would I write my vertex?
1, 4.
Alright, so I can plot that. Axis of symmetry,
1.
we have to go.
X equals 1.
Mhm. Okay, y-intercept, if I plug in 0 for all of my x's, we get 7. So I reflect that away on the other side of my axis. Domain is always negative infinity to positive infinity. Range would be bracket 4 to infinity.
Can you just say your y-intercept is always going to be your coefficient
Yeah.
unless there's like,
Your constant, yes.
or a constant?
Yeah. All right, you guys try the next one. And that'll probably be where we stop today.
Wow, this is wrong. Oh.
You're wrong. -8 divided by -4 is 2.
You have to put 2 in.
All right,
You put
let's.
negative.
Oh, yeah, you're right.
So, opposite of b, so that would be -8 over 2a, so 2 times -2. So -8 divided by -4 is +2. So we plug that in. So 2 squared is 4 times -2 is -8 plus 8 times 2 is 16.
Minus 3. That was 5.
So vertex,
2, 5.
axis of symmetry,
X
X
equals
equals 2.
y-intercept. So if you plug in
Negative
0
3.
for all of your x's, you get 0 plus 0 minus 3. So negative 3. Okay. Is this one opening up or down?
Down.
Down.
So the vertex is a max or min?
Maximum.
Max. If I say what is the actual maximum value, I'm just asking for the highest y value. So what's the actual maximum value here? 5.
Oh,
So where it happens is the vertex, the actual max or min is the y. Right, y-intercept is negative 3, so that's 2 away from my axis of symmetry. So go to the other direction.
Why did I go to the other direction?
Domain is always negative infinity, positive infinity. The range this time is negative infinity to our maximum. So negative infinity to 5.
So why would it be 2 away from?
Because look at your y-intercept. You want to reflect it. So it's 2 away from the axis of symmetry. So when you flip it over, it'll go to the other
How
direction.
did it get there though?
Because when you have,
When
since it's two,
Oh,
since
'cause it's the
vertically
y-intercept.
stretched by 2,
Gotcha.
you just didn't plot.
And there's another point at like 1.
Yeah, I just
3,
didn't
1,
plot all of our.
1, 3, and 3, 2.
Yeah.
There we go.
Okay.